number of hairs on their heads. This will require a little bit of research. So seems like a kind of a weird thing at first. So we see this use the pigeonhole principle after researching. So that's going to be a hint that we're going to want to use the pigeonhole principle. So a little bit before we get into this, let's consider the idea of if we were talking about birthdays. That will help us understand what's about to happen in just a moment. If we were talking about birthdays, if we had let's say that there is only 365 days that you can be born on. We're forgetting about leap years because we're assuming that we slide that to either the day before or the day after. So there's 365 days that you can be born on. That means if we have 366 people in the same room, we are guaranteed that at least one pair of people there has the same birthday. Now there might be more birthdays that are concurrent, that people have the same birthday, but we can be guaranteed that there is at least one pair, because if we've got 365 effective slots for a day that a birthday can be on, that's 365 boxes that a person can go into and represent I'm on that day, then at least two people are going to wind up having to be in that same box. They're going to have to wind up occupying the same birthday. Otherwise, it just doesn't make sense, right? That's the pigeonhole principle in action. This idea that if we're stuffing things into pigeonholes being a little place for a message a long time ago, if we stuff two things into the same, if we stuff, 10 messages into 9 pigeonholes, there's going to have to be some pigeonhole that has multiple messages in it, right? At least 2 messages. So if we have 366 people, we know that there's going to be at least 2 people who have the same birthday. That's the basic idea here. Now let's start thinking about this one. So we're talking about hairs on heads, we're talking about London. So first let's look into hairs on head. So we look into how many hairs are on a human head. So the number of head, a human head, assuming they have a reasonably full head of hair. So a human head with full hair has around 100,000 hairs on it. About 100,000 hairs. Now, of course, this number can be higher, this number can be lower, but it doesn't get much higher than 100,000. Like 200,000, pretty much no one's going to have 200,000 hairs. So it starts to limit out pretty quickly. So around 100,000 hairs is about the normal amount for a human head, and 150,000 would be a lot of hair. More than that just starts to become ridiculous and really hard. We figured that out with just a little bit of internet research, some cursory research. We figured out pretty quickly, it looks to be about 100,000. So at that point, we didn't do really careful scientific study, so we want to make sure that we're, giving some extra leeway here. So let's say, from this idea, the absolute maximum number of hairs that can be on a human head, the absolute max is going to be, let's just say it's 1,000,000 hairs. There can't be more than 1,000,000 hairs on a human head. So there have to be 1,000,000 hairs or less on a human head. You can be anywhere between 0, right? You can't have less than 0 hairs on your head, up to 1,000,000. And 1,000,000 is actually a ridiculously large number. No one's going to actually have 1,000,000 at all. But let's set it up to a high point that's ridiculous, because if we can show that this is true, even with this ridiculous amount of hair, we'll have proved it for a smaller, more accurate thing, what the real world would actually be. So we can set a higher set. Next idea is let's look at the population in London. So the population in London, as of the writing of this video, the population in London is a little bit over 8 million. Right? It's around 8.1 million, a little more than that. So it's around 8 million. It's over 8 million. Because of this, we now know by the pigeonhole principle that there are at least 2 people in London who have the exact same number of hairs on their head. Why? Well, let's look at it like this. So we can think of that absolute maximum of 1,000,000 hairs as being a bunch of different boxes, right? The number of hairs on a person's head. So this goes all the way out to, we've got 0 hairs at first, 1 hair on your head, 2 hairs on your head, 3 hairs on your head, 4 hairs on your head, then 999,999 hairs on your head, 1,000,000 hairs on your head. So we've got all of these different boxes that a person can go into, right? We're counting all the way up from 0 up until 1,000,000 hairs. We know that if it's a human, they're going to have to go in one of these boxes, because the absolute maximum number of hairs, and this is a ridiculous number, would be that a person has 1,000,000 hairs on their head. So that's too large, but we know that the absolute maximum number of boxes that we have to have here is from 0 up into 1,000,000 to mark out the number of hairs on a head. Now, we know that the population of London is over 8 million. That means when we go through the first 1,000,001 people, then they're each at, unless they already wind up having the two people having the same number of hairs on their heads in the first 1,000,001 people. Then we're going to go all the way up from 0 to 1,000,000 with each person having a unique number of hairs on their head. But as soon as we get to the 1,000,002nd person, they're going to wind up having to go into the same box as someone else. Someone else will wind up having to have that same box with somebody else. They'll have to share. So we've got the exact same number of hairs guaranteed. We know right this moment in London, there are somewhere in there 2 people who have the exact same number of hairs on their head. Pretty wild. In fact, because it's over 8 million, we could show that there are in fact at least 8 people who have the exact same number of hairs on their head right this instant. Kind of surprising. I won't prove why that has to be the case, but if you think about this for a little while, you'll probably be able to figure it out on your own. Pretty cool. Now, of course, there's no like practical application to this immediately. We couldn't actually find these 2 people with any ease, but it is interesting to know that there's this guarantee that because there are so darn many people in London, and there's just not that many hairs on the human head, there are more people in London than there can be hairs on the human head, it must wind up being that 2 people have the same number of hairs on their heads. So that's one way to apply the pigeonhole principle that allows us to show these really kind of surprising, strange results with not that much difficulty. All right, cool. We'll see you at Educator.com later. Bye.